expectation. So now we have a random variable. We also assume it follows some kind of distribution. What we already have noticed is that there are two key measures we are primarily looking for. The first one is where is the center mass of the distribution function. And the way to find that is to take the so-called expectation operator on our random variable. If you have ever worked with functions in mathematics, it's the same idea. We have an expectation operator that operates on everything in the following brackets. So this just means that we want to know where is the center mass of this random variable x. The way it's defined is that we need to sum over all possible states of the world. So everything that can happen, we need to take into account when we do the calculations. So we take each possible outcome, we take the probability to end up in each of these outcomes, times the value in the outcome. So we can view this as a sum of the outcomes weighted by their probability to occur. Let's look at an example and hopefully it's gonna become clear. So this random variable can represent a portfolio. So this is just the return over an annual basis. So each year we know there are three possible outcomes in the world. We either have a good period, which is gonna happen 25% of the time, and then we know that this portfolio gonna return 69%. We might also have a regular year, which is gonna happen 50% of the time. If that's the case, our portfolio X gonna return 3%. And finally, 1/4 of the time, we're gonna have some kind of recession and we're gonna lose 43% of our wealth. One thing we need to take away directly now is that we know exactly how the world works. We know that there's only three possible outcomes, three states of the world. And for each state, we know the exact probability that they're gonna occur. Moreover, we also know the exact values this random variable gonna take in each of these possible outcomes. Why I'm pointing this out is because this is so-called population. It's reality. What we're gonna run into in practice is that we never observe reality, we only observe a sample of this underlying distribution. But now we know exactly what's going on, which means that we can use the expectation operator directly on this one. And that's what I just want to show you. Let's do the expectation of this random variable x now and see what it is. What is the expected return if we hold this portfolio over 1 year? So what we want to find now is the expected return of this portfolio x. So the way we do that is that we need to sum over all possible outcomes from the first one to the last one. I'm just going to denote the last one with uppercase S. We need to take the probability to end up in each of these outcomes. So probability that our random variable takes this particular value in that particular state times the value in that state. So in this example, we know that the probability to end up in the first state, in the good state of the world, gonna happen 1/4 of the time. We need to multiply that by the return, which was 69%. Then we need to add the second outcome, which is gonna happen 50% of the time, times the value in that outcome, which was 3%. And finally, 1/4 of the time, we're gonna end up in a recession and we're gonna lose 43% of our portfolio. If we put this into our calculator, we're gonna get that this is equal to 0.08, which means that the expected value of holding this portfolio 1 year is 8%, which means that on average, if we hold this portfolio in the long run, we expect to gain 8% annually. But just note here that we might get great years and terrible years, but on average, if we hold this portfolio in the very, very long run, we should gain 8% on average by holding this portfolio. All right, that was the expectation. What is the average? What is the expected value of this random variable? Meaning that in the long run, what should be the average return of that portfolio? Next, let's look at variance.